Well, hi, Ralph here with another update video on HydraBlend technology. Um, all right, so I decided to work on yes, I decided to work on you know developing a little bit more. I worked on a little bit on database design and core project architecture and development design. So so a part of what I just did now, actually, in like a few minutes, actually, just did a little quick documentation on Packet Tracer. Uh, see if I still have it open. Yeah, so basically it's like my entire model of my infrastructure model, my home office network server infrastructure diagram. So this is basically like how my my service is really running, and this is actually within a $1,500 budget. My 800 like $1,500 bill server, and I got probably another, like, altogether I think I have like $2,200 worth of server or computer invested into this project, I guess. I don't know, this is just like a test development thing, like I'm doing I'm working on a laptop, and I'm developing the service, and I deployed the service on my server infrastructure, and my private server, and that private server is going to now integrate with the cloud eventually. So I just did a little quick diagram of how that's going to work out. And this basically describes it. So on my left side, I have development environment. I have a laptop. I did run a little convention, naming convention there. All right. Web development and testing done on the laptop using web access ports of HTTPS 443.8.443, Mongo, Oracle FTPS, and Mongo, and then I have mobile development and testing. So that's going to come around. So this entire thing is about developing an entire service all the way from scratch. Everything, all of this I've done on my own. So this is deploying and developing and administering the system for support, and also doing the development, and from my end to create a process that can really scale this application. And once this application is scaled out, I'm going to deploy the whole thing into a cloud. And this somewhat talks about some of the security through firewall that is being used here, and some networking. And it's limited networking. My network infrastructure is not huge, so it's not that complicated. And I'm also administering their task into a public cloud service, so it's going to be more or less virtual networking done, and developing a virtual network infrastructure. So yeah, like this is what I got so far, and obviously, like, home networks are not going to be that complicated. So basically the idea is that this is a home office. Okay, so I have like a router that is a home office router that's going to route into my virtual server, and this virtual server is integrated with like a logical private DMZ zone, which is like I have a virtual external firewall and a virtual internal firewall. So the whole idea is that the external firewall is ACL restricted, meaning that there's a particular computer service tag that can integrate and talk to the server, access through port 443 and 8443 with SSL enhanced, meaning that while I'm doing the development, I'm deploying my API service into the server, and the server is going to allow only ports 443 and 8443 to allow access into the web communication tunnel. And also, if I need to make some changes, I can add or remove, Oracle, Mongo, FTPS port. But these are like mass ports. These are not available through firewall, external firewall. Internal firewall, I have my virtual internal firewall, ACL internal forwarding through NAT and public to virtual. Basically, this means that there's a virtual internal firewall that's going to route the service into the virtual services and instances. So this computer over here is a virtual KVM server. This is a physical machine. The physical machine splits into 4 logical machines that is doing virtual networking, virtual communication tunneling, virtual infrastructure and networking. So I have my virtual service instances are split. I have a virtual MongoDB instance, which is UFW internal firewall enhanced. A virtual web service instance, internal firewall D service. So I have a plus 443 and 8443 port open with a maybe plus or minus 587, which is going to be in case I deploy it like a public email server integration. So this is entirely a cloud-based model. So the whole service is going to run as a cloud-based model, but this entire infrastructure in here internally, you see in the green and the orange, are going to be like, my testing production server. These are servers that I own, that I'm doing the development in and testing in, and then those test services are going to just simulate how my service is going to run, and then it's going to eventually deploy into the cloud. That's the whole idea of this system. Okay, so and I have another DBS, a virtual Oracle DB instance, internal firewall D service, port 1508, and virtual FTPS instance, internal Windows Defender AV system enhanced, and Windows Firewall port 993. So this is basically the idea is you have access to a web server. The web server itself is the only port that is accessible. Internally, the web server can internally communicate with the internal virtual servers. So these are like server to server communication, like MongoDB, Oracle DB, FTPS. All these systems are communicating inside server to server communication. There's no access. There's a filtered access from the outside developer. That's the whole idea of my Office network server infrastructure diagram. So for example, now my business model is completely different from corporations and stuff like that. Corporations are not built for remote services. You know what I mean? They were not initially built. They were initially built for a like an office kind of structure, office space structure, right? So the whole thing with big business is that they had to migrate their operations into a remote work setting. But the whole idea of building a business from your home office is that you can design your business to integrate as a home office work from home kind of model. So this is completely different, right? So this is like a new age kind of business, kind of with the current technologies available. So that's the whole idea. And I have like methodical system security approach for every single one of these services, including FTPS instance. Why did I choose Windows? Why did I choose Defender? AV system enhanced, because it's an FTPS service. So once so it's an FTPS service, but it's also integrated with Windows Active Directory. I think I showed it in my previous videos, what that is. Briefly spoke about that. So basically, FTPS service runs on a Windows Active Directory domain account, and that account is being integrated with the web service. Web service uploads a file. FTPS instance will filter the file extension. The file extension only allows certain file extension to remove any malicious files that can be uploaded, which is like an executable service or anything like that. So the FTPS service will filter any filter by file extension to only allow text files such as CSV, whatever. Internally inside the FTPS instance, I'm going to deploy and develop from scratch another program, an application service that's going to loop around and pick up files from the FTPS, is going to process the file, and internally is going to take the data and store it into the Oracle DB instance. So the Oracle DB instance are going to harbor all the data dumps, and the large amount of data dumps is going to be from the FTPS service. A process is going to dump into the Oracle DB, and the Oracle DB is going to retain that data as a form of large data collection. Now the MongoDB instance in here is talking to the web service, and the web service is basically all the information that is required to dynamically generate the Angular application in the web. So that includes references of the user. It includes a lot of dynamic generating UI templates, application logging, error, fault tolerance, stuff like that. Those things are being handled by MongoDB, and the DBS instances are running the process for the file dumps. These are the reconnaissance dumps, the Wi-Fi scan dumps, geolocation, census data, all those integrated stuff like that. And also, and finally, once I develop the service, the whole idea is that I'm going to deploy it into a public cloud service. And I think I'm going with the XaaS approach and maybe use a Amazon EC2 server. So I probably have to do a lot of work on that. But anyway, I added a task to and kind of talk about that. When it comes to core project architecture, development, design, I also talk about that, thinking about taking a course in Docker and Kubernetes to better understand that process, to see if I'm going to migrate or run any form of substance as a form of a Docker or Kubernetes service. A little bit backed up by that task. Why am I not really aggressively jumping into Kubernetes or Dockers as best practices, for my development? Is mainly because I'm using Java, right? Java and Tomcat, right? Java it has been known as a virtual machine for a very long time. They have been incorporating these practices of containerization for a long time. So they're known for that, actually. So there's really no need to do Dockers or Kubernetes. There's an entirely different architecture practice with that. With scaling those services is best run as a single instance service. So scalability, as in a Docker's form containerized application, it runs slightly differently because the whole fundamentals of that technology is using a miniaturized Linux that is connectable through SSH, and only minimize the dependencies required to install a single instance of an application, and then that application is containerized, and you allow some sort of maybe some sort of virtual networking to access this service as a containerized application, and then that containerized application can scale rapidly, right? So that is amazing. It might be a single process that's running, if I want to scale the process of an FTPS instance that is running that single process, I believe maybe something like that can be containerized and scaled individually. But at this very moment, I don't think that is required, because I don't have a large amount of data processing and the ability to see where my application is going to require that form of scalability. So right now, it's something that I'm considering for the future, but not now at the moment. So this is not the highest priority in my development. So okay, anyway, secure connection, IPv6, TLS, SSL. I'm going to use that model for communication networking through public cloud. EC2 Amazon service, XaaS, SaaS, and IDaaS. I think I spoke about IDaaS as in I'm using Facebook as a identity public cloud system. Infrastructure being hosted on Amazon, maybe, and restricted access through port 443 only with TLS enhanced production development. Okay, public cloud. Okay, so yeah, that is the whole business model, and I'm developing this entire thing from scratch. Every single layer of it is what I'm going to implement in my work and showcasing my skills and talent. Okay, so this is, and if I can get this done, it'd be nice. That's basically it. I don't know what else to do in this pandemic. But anyway, and one last thing. So finally, and I also did a little bit of work on my API development. I'll just do a little update on that. So basically what I've done, one of the things that I've done in my API is I go to my data seeder, and I actually migrated the HydraBlend modules into a JSON template now. So I've got rid of all that the code that I had sitting there, as in it's looked like it was hard coded or something, and I moved it into a JSON format. And this is now dynamically generated from a JSON format. I started realizing the scalability required for this class as I'm dynamically generating data. So a part of that, I created a new data I call Endpoint API list. And I'm going to explain how this Endpoint API list is going to integrate with third-party API systems to create integrate large data and analytics. So let's talk about okay, so basically I have this resource, and I call it an endpoint, if you will. Before I go to that, I go into modules, and basically this module, this JSON format is going to have all my modules now. Okay, so this is now a JSON file. If I want to add a module, I can just add a new JSON template and create a new module and just fill out the details in here, and it will dynamically generate by reading this JSON file and inserting that data into the database. And finally, I decided to create something similar for an API endpoint. So this is different. So what this service is actually let me logging is creating a log for third-party API systems. Okay, so because I'm a home office, I cannot retain large data. So what I'm doing is I'm administering the cost by using other third-party open API systems. And by using their data, I can integrate their data to create more meaningful analytics tools and more meaningful analytics trends research and stuff like that. So a lot of my work is also going to be statistic based, mathematical statistics, anomalies, stuff like that. So really going to focus on the data analytics side in the future. But for now, let's talk about just organizing that data to begin with so I can do further work and research. So in here I have this open API system, and this is actually a really stupid challenge I saw in the front end Angular application, which is, I was thinking of a way to, instead of creating countries like location based, I wanted to see if I can just run it from a drop down list. You know what I mean? So I don't want to allow the user potential to fill out the wrong information. So therefore I want to give them an option. So what I did was I went out the easiest way, instead of creating that data and hard coding or putting it into my database, is to look at it into an open API database. And basically what I've done is, I found this open API service that allows me to query into third-party API systems. And then basically what I've done is model their API in my database. So this is an open API system. This allows me to search open API data, search countries, and they have a whole bunch of information here. It's pretty interesting, actually. I go into, for example, if I run this API call, I will see a list of all the JSON data for countries. And they have quite the information. Let's say they have a country, they have the country code, they have all these kind of information. I think this is somehow archived as a universal UN kind of thing. They have a population count, they have a location, region, area, they have native languages, borders around surrounding countries, so you can create a geographical globe kind of thing. So you can also relate it with other country codes, which is interesting. They have time zone, they have currency, which is another interesting thing. Okay, currency. And then they have language, right? Language, they have translation, they have a flag, link, I guess. So a link to a flag picture. What this is, I don't know, South Asian, some sort of association, regional blocks association, which is interesting. Maybe I can do some third-party analytics with more focused on country to country base in the future with their API system. But for now, all I really wanted was their the name and their 3 alpha related code. But anyway, what I've done is that I took in their data and I basically modeled it in my database, as in how their API template looks and feels, so I can dynamically manipulate their API template by using their documentation and creating a dynamic template for their API, so I can navigate through their API through my own database. Does that make sense? It's basically what my API system is going to do is going to dynamically generate the URL code, the URI code for the API system, and I'm going to be able to filter and query through their API system by modeling it within my database. So that's basically what I did. I have a domain, I have a description for what this domain is, I have the base URI, I have the documentation link, I have all the filter fields that I can utilize, and I've done it. I actually did a string, like a string format that I've kind of generated in my own kind of way. If I have a question mark, I view it as an optional parameter. So if I want to do some sort of string algorithms, write some string manipulation algorithms, I'm going to take that. I'm going to take the different basically the different structures of the values, and I'm going to replace that value with the actual values. For example, there's going to be a query through name, a query through capital, query through alpha code, and without hard coding or within my own database, I'm going to allow this data to be dynamically generated from their base API system. Okay, so basically I put out all those fields out and even parameters. And basically it really maps into what they have in their documentations. For example, like, the URL pattern for searching by name is going to follow this convention, or is going to follow this convention, and with a additional filter, something like that. So I actually model their API call in my database similar to that. If I have a parameter, I have a like added name, and then add a parameter which is going to fill in the name value. Or if and once I have the name filter, I can filter furthermore with other values. So this is the whole idea. Like I modeled their entire API just like that to really utilize their API to dynamically generate data from their database. So basically, my API system integrates with Oracle DB, it integrates with MongoDB, and it integrates with other third-party API systems to create calls to generate the data dynamically and stuff like that. And the whole idea is that I'm going to take this their API documentation. I'm not going to build models in my API to parse into models. I'm just going to take their data, call their data, and return it to the user. So it's just a filter process that's going to take a request, send it, get the data, and give it back to the user. So without taking too much process in doing that, I will just do that. And all I really want is that the user is authenticated with my system to allow that to happen, and then also and run the audit logging and stuff like that. The reason is, it's just a traffic, it's just like navigating traffic between data, and and for the user, is also logging error handling and stuff like that. So this is just this is just a filter for the request, and allow the user access into data. It's just the best model. The other way I could have done is just dynamically call this API from the front end application, but it's not scalable. You know what I mean? It's not scalable. I have to do it individually for every API, and my fear is that statically hard coding that kind of information is going to limit my ability to really retain large data analytics. Okay, so this is also a software architectural design. All right. So finally, once I have this, let's talk about the future of third-party API integration. I have a whole bunch of APIs that I can hack. I have New York City open data for New York City crime. I spoke about this previously in my videos. I'm going to model their API eventually, and I'm going to mine their data. I got the census that I can use. I'm going to model their API, manipulate their data. And also we have this directly from the NYPD, we have crime statistics by area. We could by borough. This is actually from New York City. This is NYPD, but I can theoretically write the same thing for Chicago. I can do it for Florida. I can do it for a list of things. There's a lot of possibility here. So like for example, Brooklyn North. Let's do a query, and then we have all these kind of situations. We have murders, we have statisticals of all this kind of stuff. This is very interesting to me. Jesus Christ, there's a lot of things I can do here. So you'll see that my application is really going to allow a lot of work, a lot of versatility of work that can be done here. And I'm going to utilize it to give people power of information and mining data to allow many different kind of services. So this is pretty interesting. So this is going to give you a really solid control of knowing your area, knowing the value of property around you. That's another thing I can do, like rental property values by a distribution, but it's going to really be able to find correlations with large sets of data. But that's the whole idea, but it's going to take a lot of statistical analytical work, a lot of mathematics, and potentially possibility to integrate machine learning algorithms to design like predictability natures and stuff like that. But who knows, but that's a lot further down the line. But this is the baseline development that I have so far, and that's really what I wanted to leave off with. I've done this much within a day. I guess I was like, today I was a little bit bored than usual. It was raining today, so but anyway, I'm going to go ahead and model that API system and create some mapping with those endpoints, and I'll do some of that work now, continuing on the development of HydraBlend technology. Thank you for your time, and appreciate people watching this. Thank you.